All right, so it's time for the last presentation. Thanks for the introduction. As Eva said, it's about PostGIS, or storing your file, your data in a spatial database in general. And actually, so we're gonna talk about databases and data types a little bit. I'll show a little practical example and then we'll go over to the summary. So, not the biggest agenda. Actually, first of all, when I made this presentation, I wasn't sure what the audience would look like. So it seems like we have a fairly experienced audience in terms of spatial data handling, but maybe as a little survey in the beginning, who of you has never successfully typed in a PostGIS query and executed it on a computer? Hands up. Okay, nobody. So everybody here has at least touched PostGIS. So then maybe for some of you things might look a bit trivial, but nevertheless, I'm gonna introduce you to spatial databases. Maybe as a little other goal, the shapefile must die is a website that's created by some guy who doesn't like the shapefile format. Actually, because of two combined issues that were touched on before, namely what Steffen and Nico showed. Because, first of all, shapefile is a horrible format, because there's just multiple files sitting around on your computer, and it's very disorganized, and you also have no real way of versioning it. And if you change something, then I've seen that in practice, people tend to like clutter up their entire machine with version _2 final blah 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 and create their own little hell. And I want to like help you out of this. And in the end, because there will be some like simple copy and paste commands that you can try yourself at home. And if you've never done it, but you have, I encourage you to try and play a bit with PostGIS and see what it can do for you. So first of all, just really basic from the beginning, why should you use a database to store and organize your data anyway? Fair question. You could just put it in a file and have it sit on your computer. First of all, it's a bit more reliable in general. Because databases have mechanisms built in that ensure that your data is consistent, that certain backup mechanisms can be executed really easily. So it's built to store your data in a reliable and secure fashion. You can have multiple users accessing and managing your data, and setting that up is really easy as well. It can easily live on a server where multiple people have access. So that's also something that's close to impossible already with just regular files. You can build stuff like indices, that can speed up your processes. That means that you're basically sacrificing a bit of space on your hard drive in order to pre-order some of the data in your database, and then you can find data later on quicker. Sometimes you have maybe complex queries, because you don't always, when you retrieve your data, you don't always want like all of your data that you have returned back to you, but you want to refine your results maybe by some predicate that you can put on the data. And those queries that you build there, they can get really long and complicated. And if you use a database, you can easily store that. You can repeat queries that you did before. So it's So it's easy to replicate your old queries, and you can extend them. And also, because of all of the above, if you work with data a lot, you hopefully do try to automate a lot of your tasks, and that's also for many things like, I don't know, automatic quality checks and whatnot. It's fairly easy if you use databases for many applications. Now, why should you use not only databases, but spatial databases? First of all, because all of this. And second of all, if you use a spatial database, you get, first of all, spatial data types, but I'll touch on them a bit later. You get spatial functions that allow you to use spatial operations on your data, because this is like mainly focused on PostGIS. If you look around in your database and look in the functions that you have, if you have the PostGIS extension installed, you will find a lot of st underscore whatever functions, and they are not exclusively called st underscore, but also a bunch of others, but those are mainly your spatial type, hence the st operation. So, in case you ever wondered why it's always st, I did at some point. Yeah, what can you do if you use a spatial database? You can have your queries based on the location of your data. So, for example, I don't know, what are the restaurants near me? That's in a spatial database a fairly easy question to answer, but if you don't have a spatial data type, then that's really hard. You can do all sorts of geometry calculations or interpolation and all kinds of GIS functionalities, basically. You have, on top of that, you have spatial indexing, which is like regular indexing, but in space, which makes it cooler. And you've got spatial joins as well, like, so, like you could use, regular joins in order to request data from different tables. You're, based on a connecting feature or attribute. You have spatial joins as well that allow you to use the location of your features. And that can be fairly handy as well. I mentioned spatial data types that you have. So, PostGIS offers both vector and raster support. I think it's mostly being used for vector because I think there's specific or more specific ones for raster data. I'm not so sure about that. And the two big ones that you fairly often encounter are geography and geometry. They do roughly the same, so they are not bound to any of the simple to any one of the simple features, like for example points, lines, polygons, or the more fancy combined versions or other ones. But they are mainly used in PostGIS tables, and they differentiate in so far that the geography data type actually does calculations on a sphere, and that comes with a bunch of implications. So it's not as in as many functions implemented as the geometry data type. I think basically all of the st underscore functions work with geometry. Not entirely sure if that's really all, but most of them, and only a few of them at this point, but I think it's getting more and more are working with the geography data type. And that, of course, leads to, yes, please?
When do you recommend geography over geometry?
Depends a bit. I know it's the I would say
You can give a case when you would use
like if you have, for example, a shipping route from Europe to the US, then Earth curvature really does a lot to your distance between the 2 points, because, you know, if you just have it on a planar coordinate system, then you get a fair bit of distortion there. So the smaller your target area is, the less critical it is for geography. And also sometimes it's just a question of practicality. So if you've got like 1 billion points and you want to like look if they're in some area, we're going to look at that example later on, then it's just awfully more expensive computationally to use geography. So it's always a bit of a trade-off. In general, I would recommend to, when you can, use geography, but then you should first really check if none of the functions in your workflow, or if all of your functions in the workflow can also deal with that format. Good question though. Yeah, that was already the the theory part. I just brought a tiny bit of a practical example. So if there were people in this audience who have never seen a SQL query, this is what it looks like. It's not overly complicated, this one. So in here we just generate a bunch of sample data with points in it. So first we'll create a table that can house some points. It's called test point. And this is actually even for the more experienced people amongst you, this is what I use fairly often to just generate random point data because I need it for some tests. And I think there's nothing pre-made in there, so you can just feel free to copy that. I think it's on the GitHub repo of Maptime, yeah. So we're inserting basically a bunch of 1,000 points in this table. Make another table with 1 polygon in it. Who knows where that is? Switzerland. So this is what it looks like. We got a bunch of points and we got a polygon. And just based on that, I will just show you some very, very basic features, but if you've never seen that before, you will be amazed. So first of all, we have a simple non-spatial query. So we select, you know, how many features are in that table with the ID greater than 200. So they have this serial ID from 1 to 1,000. And big surprise, it's 800. And here's what the result would look like. So there's still this other polygon overlaid, but here in orange you see the selected ones, and in blue the ones who are not selected. So it's basically just a random selection. We also can have a spatial query, and now we count how many of our points are actually within that polygon. So we're doing a spatial join, which I mentioned earlier is useful for some applications. We get a result, and it would look like this on the map. And now, in turn, I'm not expecting any of you to like fall over backwards from your chairs, from the amazement, but we can combine these two and actually count how many fit the first predicate, which is they are within that polygon, and also fit that predicate ID over 200. And we get a few less, of course. Looks like this a little bit. Now this is not the amazing part, but it should be painfully obvious at this point that you could extend this to however complicated you want that to be. And the power of doing that and storing that and repeating that, that is actually one of the big leverages that I wanted to show to you with this presentation. So, very short summary. Please do use spatial DBs. This is also self-service in a bit, because if we are collaborating, then I don't have to deal with shapefiles that you sent me, for example, which is also nice for me. And I would really try to encourage you to try this at home. So you can just copy all of these commands here, paste them in your spatial database, and it will run the exact same queries, and it will just work like that. So all the data generation in this as well. Here's links to the software you need, documentation, other things. This is a very nice community for all sorts of related tasks. My website for if you're interested in what else I do all day. And that was it already. Thanks to you and to the organizers. And if you have questions, feel free to ask.